Hello everyone, today we're going to be going over some Blind 75 C++, and today we're working on the problem same tree. Now before we break down and go over our question, we need to ask ourselves the for question, what are inputs going to be? I'm going to just copy and paste for the rest, you can follow along too. What data structure / algorithm / technique to use, what to do with the data, and then finally what our output is going to be. So to be able to break down the following problem, what we have is that we were given the roots of two binary trees, P and Q, okay? Trees, P and Q, especially specified by the parameters up here. Run a function to check if they are the same or not, all right? And what to do with the data, we are checking to see if they are the same or not. And then we will be returning true if the same. So the technique we will be doing is depth first search, namely, to be able to make a comparison between the two, where depth first search pretty works and is really extensive, given its space and time complexity that we would use and keep everything within the constant space. And so what we will be doing is that we're going to be checking on the different values between all of our null, all between our pointers, between if one of P or Q is null, or the values are not equal to each other. We're going to be having one condition where it's going to be false, and then we're going to see in particular if P or Q are going to be matching up. So use this technique to check their pointers first, and then we also do a recursive call to check to see the left and right subtrees of P and Q just from the roots. For depth first search is known for recursion. So to be able to break down the steps, or what we are going to do, step one, we are going to we're going to be checking if P and Q are null, return true. And then for the second part, if one of P or Q is null, or their values are not equal, return false. And then we're going to be recursively calling the function for the left subtrees of P and Q. And then we will be doing the same thing, but for the left subtrees. So we're doing this for the left and the right accordingly. And then we will be returning the results of the recursive calls for both the left and right subtrees. Okay, so here we go. So to be able to break down the whole problem, or what we will be doing, we're going to be focusing our null pointers to be able to initialize steps 1 and 2. So if P, the root, is a null pointer, and Q is also a null pointer, we're going to be returning true in this case. And then if one of P or Q is null, they are not equal. So if P equals null pointer, or Q is equal null pointer, or we're not doing this and up here and condition, or P value does not equal Q's value, we're going to be returning false. So then we cover that. Now we are going to be doing our recursive call with DFS. DFS recursion. So we're going to have one function, boolean is left, same is same tree for the left side. Q left. This is typically called within the STL library for the following tree that we're also calling is right same. We're having this boolean is same tree, where we're calling upon this function right over here, our boolean condition, to be able to check for the subtree as well. So then we are going to be setting the left subtree that we have inside of our function right over here. So this will be a form of recursion. So P to the right, and then Q to the right subtree. There we go. And our output, return the conditions of both the left and right subtrees. Since we've already took care of our nodes of our given tree, now we're focusing on the subtrees. Since it's very easy to figure out between the first two, we're going to be focusing on the nodes of the tree, or the root slash head of the tree. So then we'll return is left same and is right same, because both of them need to match up accordingly. We're checking for every single value that we can find, and we are setting P, the parameter, to our left, and then Q to our left as well. We're checking them all together and doing this recursive call that is made accordingly. And we are already given the values of left and right in our tree structure that we can call from the STL library. So let's just double check to see if this is all right. So it's accepted. Okay, let me just clean all this up for you folks. This is step 1, and this is also step 2 right here. And then subtrees. It's all accepted. Just want to be sure I get everything right. And we'll submit this. Okay, and just to give a breakdown on everything that we've done. So the time complexity for our following solution is going to be O of n, given the fact that n represents the number of nodes within the tree. And the space complexity for the following is going to be O of h, where h represents the height of the tree. So therefore, it would all run within constant space. And we do this by using depth first search to be able to make recursive calls for our following solution right over here. So yeah, this was same tree in C++. Thanks again for taking time to watch this. If you found this helpful, like and subscribe. And if you have any other questions, feel free to put them in the comment section. As always, take care. Cheers. Bye-bye.